Hello everybody, Mr. Krebsbach here talking to you about March Number Corner, day number 4. We're going to be working on a problem string, so we're going to need a notebook and a pencil. And our problem string today involves adding fractions. Now, we're definitely getting into some advanced 5th grade math today in that the fractions that we add are not going to have like denominators. All right, remember when we started adding fractions way back in 3rd grade, we'd get 1/3 plus 1/3, and we'd be very impressed with ourselves when we ended up with 2/3, knowing that, we have to plus the numerator, but the denominator stays the same. Well, like it or not, we're getting older, and our problems are getting more difficult. So when we're adding fractions in 5th grade, the denominators most likely will not be the same. So we have to have some strategies. Okay? Now, we've talked at great length this year. This is not the first lesson where we've talked about we need to get like denominators, and in order to do that, we have to think about factors that are in common. So we see the 4 and 5, and remember the quickest way that you can get common denominators is to times them together. 4 times 5 is 20. So if we times the 4 by 5, we have to do the same to the numerator. 1 times 5 is 5. To get from fifths up to 20ths, we have to times by 4. So for 1/5, we would times that by 4, and we end up with 4/20ths. Now, 5/20ths plus 4/20ths. Now, just like in the thirds problem that we did, when we add those together, we end up with 9/20ths. Now, many people see that fourths and fifths can become hundredths. Okay, now that's all right if we just want to go the easier route and change those into 100. If you have a fourth, that means you have a quarter. So you'd have to times that by 25, and you would end up with 1 times 25 equaling 25 100ths. Fifths, we would have to times by 20, so we end up with 20 100ths. Now, the only issue that we have as we're adding these up is that we end with a large numerator and denominator that have to be reduced. So we look at 45, 100, they both are multiples of 5 because they end in 0 or 5. So we just have to divide both of these numbers by 5 in order to get our correct answer. 45 divided by 5 is 9. 20 divided by 5, 100 divided by 5 is 20. Okay, that gives us the same answer, 9/20ths. We just have to do one extra step. All right. On to 2 1/4 plus 3 1/5. Now, I want you to notice that our fourth and our fifths are identical. We just are now adding mixed numbers to it. So many people like to say, I'm going to deal with the whole numbers first. 2 plus 3 is 5. My 1/4 and 1/5, I don't know, let's change those to 20ths again, right? Times by 5, so we get 5/20ths plus 4/20ths. Okay, that gets us to 5 and 9/20ths. Now, here's where some people really like to push themselves. They like to change these mixed numbers into improper fractions. Now, in order to do that, you would take your denominator, fourths, and times it by the whole number. 4 times 2 is 8, plus 1 more fourth is 9/4. Right? We can also get that by saying the number 2 is 4/4 and 4/4, which is 8/4, plus 1 more is 9/4. Or you can just use the strategy I showed you of taking your denominator, 5 times 3, 15, plus 1 more is 16/5. Right? Now, again, watch how tricky this gets when we times by 5, 4 in order to get our denominators of 20. So we would have 45 twentieths plus 16 times 4. Well, I'd have to double my double, so 32 plus double it again, 64 twentieths. I would end up with 109 twentieths. Now, in order to get my answer of 5 and 9 twentieths, I can't leave that as an improper fraction. So I look at my twentieths and I say, how many whole numbers can I take out of 109? Well, I could take 5 twentieths, right? That would be 100 twentieths, and I would have 9 twentieths left over. Again, the same answer. It's just some people like to change these to improper fractions. We'll look at that one again here in another problem. So what if we have 3 fractions, a third plus a fourth plus 1/2, and that's all right. 3, 4, and 2. If we times those together, 3 times 4 is 12, times 2 is 24. We can deal with 24s. Or hopefully you know that 3 times 4 is 12, and we can make our halves into 12s. So let's turn these all into 12s. We'll just have different numbers we have to multiply by. To get from thirds to 12s, we have to times those by 4. We'll have to times fourths by 3. And our halves will be times 6. So 3 times 4 is 12. That gets my denominator, but 1 times 4 is 4. We've got 3 12s. We got that by timesing 4 times 3 to get our 12s. 1 times 3. And then finally, 2 times 6 is 12, and 1 times 6 is 6. So we end up with 4 12s plus 3 12s plus 6 12s, 10, 13 12s. We can't keep that as an improper fraction, so our answer would be 1 and 1/12. Now, how could people make that real difficult on themselves? Let's go take a peek. What if we had 2 1/3 plus 1 1/4 plus 3 1/2? Okay, this is a problem that you could very well see on the MCAs. Now, what all of us 5th grade teachers hope is that you would go and take the whole numbers. 2 plus 1 is 3, plus 3 more is 6, plus your 12th, 12th, 12th. And again, you would times 3 times 4, 4 times 3, and finally 6. So we'd have 3 12s, 4 12s, 6 12s, and we would end up with 6 plus 13 12s. Again, 13 12s is 1 and 1/12, as we just learned. Final answer would be 7 and 1/12. Now, why in the world someone would do this to themselves, I have no idea, but they do. They would change this to an improper fraction, all of these first. So they would do 3 times 2 is 6, plus 1 more is 7/3, plus 4 times 1 plus 1 more is 5/4, and then 7/2. So again, they would want to change these to 12s. Times that by 4, times 3, times 6. 7 times 4 is 28. 5 times 3 is 15. And 42. So I take a look at that and I say, well, let's add 28 and 42 because I can make a 10 pretty easily. So that's 70 plus 15 more is 85/12. Now, having a really good knowledge of my 12s facts is pretty important. So I know that 12 times 6 is 72 because 12 times 12 is 144. So 12 more there would give me 84. So I have 7 whole, and there would be 1 left over. Again, can you change these mixed numbers into improper fractions and do them? Yeah, but for me, it makes a whole lot more sense to go steal those whole numbers, 2, 1, and 3, and get 6, and then just deal with some smaller fractions. All right, you need to go and take a peek at the questions below. Good luck on adding your fractions.